Hello guys, it's Mrs. Brabant again. We're now finishing up target 4 in Unit 3, which is simplifying polynomials, and that's where we possibly get all kinds of operations. In other words, we might be multiplying things, we might be adding like terms, all of the above might come up. Now some of this will seem super simple or super similar, to the second target that we did, so there is some kind of an overlap. All right, number 1. If you look really close, this is just really distributive property, but it's 3 different times. So it's likely that we might have some like terms. So just be super careful. We've got 3x minus 6 plus 4x minus 4 minus 10x minus 3. Remember, you want to be super careful with negative signs that are involved right there, simply because some people just kind of forget to do them. And now x's with x's, so I underline constants, meaning numbers with numbers. Watch their signs that go with them. So it looks like we've got a 3 and a 4 and a negative 10. So we've got 7 minus 10, that's negative 3x. And we've got a negative 6 and a negative 4, that's negative 10. And then another negative 13, or 3, that's negative 13. You always want to check and see if you can do anything else with combination. You don't really want to go backwards and factor. We're not really there yet, so it's okay to leave it as is. Second one, it's the same idea. It just, as you can see, it's getting a little messier because of all the power. So you just want to be super cautious. X times x squared is x to the third. X times 4x is 4x squared. And x times negative 1 is minus 1x. You don't really need to know. Going over, there's a plus sign, that's happy. 5x to the third when we multiply, and then 5 times 4 is 20, and then that x just leaves out. So again, we want to look for like terms. Is there any other x to the thirds? Sure, we'll put those together. Is there any other x squared? Nope, that's going to be by itself. Is there anything with a negative 1x, or excuse me, just an x to the first power? Yep, right here. So combine like terms. So 1x to the third and 5x to the third is 6x to the third. Oh, look at that cookie here. Sorry about that. I'm going crazy. And now let's do in order, standard form. The next power is the second one, but there's nothing together with it. And then the next power, we've got negative 1. Positive 20, that's just like 20 minus 1, so that's positive 19, and that is an x. There you go. Now I'm going to say to you, if you take a look at this one, this is just really like target 2, and it's simply, I'll just be honest and say, a very messy exercise of being super cautious with how you put things together. I'm going to not do number 3 since we've done one similar to that in the other target 2, excuse me, but I am going to work out number 4 just because it's so long. We want to be cautious in our like terms. So give yourself a lot of space when you're doing ones that have, like you have a trinomial times a trinomial. Both of the degrees are 2 and 2 there, so that's going to get a little larger. So what I like to do, and there's a different way to do this. I'm going to take each one times the second, each one times the second, each one times the second. And then I kind of stack them. So x squared times what I see. Again, this is an exercise in patience and organization. Next one times the same darn thing. Some people do not need to rewrite this. It just makes, I like to because it keeps me organized. You just want to be careful if you're holding it in your head. You tend to lose your organization. Okay, so then this is just me doing each problem, and then when I am done, I'm going to want to combine like terms. I'm going to scooch this over just a smidgen because I know I'm going to need more room, especially when I start underlining like terms. All right, let's go to the first part. 4x to the 4th. That's probably going to be by itself because I don't see anything else below that's going to be next to the 4th. Minus 5. There's 3 x's and then that y. That might be a like term coming up again. and then just negative x squared. So I'm just going to look for other like terms as I multiply, and if I catch them, I'm going to stack them together. If not, I'm just going to be cautious. Next one, be very careful, negative 12. Let's look at my powers real close before I write them. I've got 3 x's and 1 y. I'm going to stack it under this guy. So negative 12, 3 x's, 1 y. This one now is a x squared, y squared. That doesn't land with anything, so I'm just going to, it doesn't have to be stacked with anything. So positive 15x squared, y squared. See, it's so different than all the other ones. I didn't stack it. And then the last one is a positive 3xy. That's not stacked either. So I kind of am trying to just organize in order. Sometimes it works, sometimes it doesn't. Last one here, 8x squared, y squared. I have that right here. So I'm going to stack it. 8x squared, y squared. Negative 10, 1x, 3y's. That's nowhere else. Negative 10, 1x, 3y's. Oops, I'm running out of room. And then this is by itself, minus 2y squared. So I'm going to have to be careful because I got some things hanging out here. So when I put these together, I really only have these two going together. And it looks like these two. Everything else, just when you're up organization, if you look straight down like in rows and columns, nothing else combines. So this guy is by himself. He's going to go out in front. And I'm not even going to really worry about standard form because there's just too much involved here. These two now go together. So there's where you want to go negative 5 and negative 12 is negative 17. And then you literally just recopy that because you're not changing any powers when you add. Now I kind of have this negative x squared hanging out there by itself with no partner, so I just write it down. And now I've got a combo. So see, I gave myself a visual clue of what I need to put together. So those two go together. They're both positive. They're going to turn out 23, and then I just literally write down the same thing that I counted, not changing the powers. All of these are separate. They don't look like each other, so I can't combine. So I'm literally recopying what I had. Again, this is just an exercise in slow, organized, distributive property. It's just the messiest stone formula ever. It doesn't really give you a nice ordered pair. So that's target 4. I will post that for you, and you'll be ready for your exam.